Good morning, everyone. Just waiting for a minute for others to join. So today we are going to start with exercise 10.1 circles. And you have to do this exercise in fair notebook. And good morning, everyone. Okay, now starting with the class. It is 11:03. I'm just waiting till 11:04. By the time read the filling the blanks and try to solve it out. We have discussed yesterday all the things which is written here in true and false in filling the blanks. Okay, now filling the blanks. The center of a circle lies in dash of the circle. The center of the circle obviously lies in interior of the circle. Center lies in the interior. Okay. Next. Yes, you have to. A point whose distance from the center of the circle is greater than its radius lies in the dash of the circle. A point whose distance from the center of the circle is greater than its radius lies in dash of the circle. What they're talking about, see this, there is a circle and this is the center. A point whose distance from the center is greater than radius means if I am talking about a distance from the center till the point on circle, then this is called the radius. If there is a line from the center and it is greater than radius, then obviously it will lie outside the circle. If you will draw a line from the center greater than the radius, then the point will lie outside the circle. So we have to write here exterior. After this, the longest chord of the circle is diameter of the circle. This we all know. These are basic things. And an arc is a dash when its end are the end of the diameter. See this? What is this? A semicircle. Fine. If I'll talk about this, this is a radius and this full is diameter. So this is an arc. An arc starting point and end point are the starting and end points of diameter. So if there is an arc whose end points lies on diameter, it means it is a semicircle. So we have to write here semicircle. Segment of a circle is the region between arc and dash of the circle. I have told this yesterday. Segment, what do you mean by segment? It is between arc and chord of the circle. See, yesterday we have done this. Between arc and chord, we have segment. Between arc and chord, we have segment. So that's why we have to write here. It is a area between arc and chord. A circle divides the plane on which it lies in three parts. Yesterday we have done this. Three parts: exterior, interior, and on the circle. Okay, so these are all the filling the blanks. Now going to true and false. So let us discuss this. And now I have written all the answers. So this is all I know. Let me write. So still we should discuss whether you know or you don't know. Line segment joining the center to any point on the circle is the radius of the circle. It means if you are making any line segment from center to the circle, see, from center to the circle, from center to the circle, from center to the circle. So these all lines are representing radius. So it is true. A circle has only finite number of equal chords. No, you can make infinite equal chords. So this is false. If a circle is divided into three equal arcs, each is a major arc. No, it is not possible. See, let me tell you this. See, there is a circle. And I am dividing this circle into three equal arcs. So let it be like this. I'm trying to make equal arcs. Suppose these all are equal arcs of 120 degree and 120 degree. So I have made equal divisions. See, 120, 120 and 120. Complete angle is equal to 360 degree. So it is justifying. So we can take three equal arcs of 120 degree each. Now, this is a minor arc or a major arc? This is a minor arc or a major arc? This is a minor arc or major arc? See, let me tell you now what is minor and major arc. This is a diameter AB. If you have arc from, suppose from C to D like this, then it is a minor arc. If you have arc which is greater than, see, starting from this point and ending after the diameter. Okay, if it is, if the end points of the arc are after the diameter, it means they are major arc. Means you can say that this is a major arc. Okay, minor arc lies before the diameter. Minor arc lies before the diameter. So it is like this. If we have a circle and a diameter, then these are minor arc. This is minor arc. From here to here, this is minor arc, like this. If you will take from here to here, then this will become a semicircle. If you will go more than this, if you will go more than this, then this will become major arc. It is like this. So three equal arcs, if you will draw, no, then all will be a minor arc. It will not be a major arc. So false. A chord of a circle which is twice as long as radius is diameter. Correct. The diameter is twice of radius. Correct. Sector is a region. Sector, I have told you yesterday. Sector is a region between arc and radii. Okay, let us see here what is written. Sector is a region between chord and arc. That is wrong. False. Circle is a plane figure. True. Some students have come late. It will not be allowed this way next time. Okay, you should come on time. before 11:03, because at 11:03 I'll start the lecture on daily basis. So this is done. So first exercise is done. So now before starting exercise 10.2, we have to go through with some of the theorems. After the proving of the theorems, we can do exercise 10.2. So before that, we have to start with the theorems. So we are starting with the theorem. I hope you've done this. Right now, write the heading theorems. Yes, you can write it on the same page. Now, write the first theorem. Write th dot theorem 1. Now, these theorems are so important. I am not just saying it that the theorem will come in exam or it will come in test. No, not from that point of view. I am just saying it. Yeah, it can come in test or exam, but my point of view is the theorems are very important to understand the chapter. Theorems are very important to understand the chapter. Understood? Yeah, if you will be able to understand the theorem, then you will be able to apply these theorems in the questions which will be asked in the next exercises. So the questions given in exercises are all based on, I think there are 10 theorems in the chapter. Okay, so we have to apply theorems to solve the question. That's it. Yeah. So equal chords of a circle. This is one of the theorem. Equal chords of a circle subtend, and yeah, you have to write, semester, you have to write the theorem. You have to write the theorem. You have to solve the theorem. Okay, in your fair notebook. Equal chords of a circle subtend. Subtend means to make. Equal chords of a circle subtend equal angles at the center. Okay, then let me make the circle. Equal chords of a circle subtend equal angles at the center. So I'm making two equal chords. One is this. So let these two chords be equal to each other. So AB and CD, I have drawn two chords. You also have to draw this. And after that, join with the center. I am making this figure as per the theorem. I'll explain you that. Now look, equal chords of a circle. What it is written? Equal chords of a circle. Try to understand it carefully. Equal chords of a circle. So I have made equal chords. AB and CD be the equal chords. So I am writing here in given that the chords are equal. AB is equals to CD. Subtend means they make equal angles at the center. So equal chords make equal angle at the center means let this center be O. We have to prove that angle 1 and angle 2 are equal. Angle 1 is made by this chord. See, with the end point of this chord we have made this angle at the center, and with the end point of this chord we have made this angle 2 at the center. So right into proof, we have to prove that according to the theorem that angle 1 and angle 2 are equal. After that, no construction required, nothing. Start with the proving. And the proof is so easy. Just take the two triangles in triangle AOB and triangle COD and do the congruency that you all know much better. You have given the exam also. Now angle I'm talking about, I'm saying that AB and CD are equal as it is given in the question. Yes, we have to write reasons. Okay, AB and CD are equal. And after that, see it carefully. This is radius. This is radius. This is also radius, and this is also radius. All are the radii of the same circle. So AB and CD are equal. Now after that, you can write that AO and OC are equal. AO is equal to CO. And after that, BO and DO are equal. BO is equal to DO. And reason is same, radii of same circle. In a circle, in a same circle, if you will make different radius, then all the radius will be equal to each other. Means all the radii will be equal to each other. So radii of same circle are always equal. So you have to just write the reason, radii of same circle. So triangle AOB is congruent to triangle COD by triple S congruence criteria, and by CPCT we can write that angle 1 and angle 2 are equal. So it is proved that yes, equal chords do subtend equal angles at the center. If two chords are given equal, it means the angle subtended by these two chords will be equal to each other. Now keep this theorem in your mind. We have proved also, so that it should be there in your mind now. Yes, if equal chords are given in a circle, then they will subtend equal angles at the center. Navan is asking, sir, can't we write AO and OD together? Means AO is equal to DO. AO and DO are also radii of the same circle. We can write, but we should move according to the naming of the triangle also. I have written the name of the triangle like AOB from left to right, AOB, then this also from left to right, COD. So corresponding parts are AO and CO. See this AO and CO. And fine. And BO and DO. See on the same place. AO, CO, BO, DO. So these are the corresponding parts. So we have to write this way. Clear? Note it down. Then we'll move to the next, the converse of this theorem. We have to do these two theorems, then we'll do the exercise. Good, Navan. Just right after this, hence proved. If somebody has any problem related to this proving, if any confusion is there, you can ask. Otherwise, it's done. It's a simple congruency by triple S, the easiest one. Now converse of this, write the next. If the angles subtended by chords of a circle are equal, then you have to prove that the chords are equal. Note it down. If the angles subtended by chords of a circle are equal, means if the angles are equal, then chords will be equal. Obviously, this is the converse of that theorem. See, in the previous theorem, we have done that. If the chords are equal, then angles are equal. Angles subtended by the chords are equal. That we have proved. Now it is written, if angles are equal, then chords will also be equal. It is justifying the statement. So let us prove this. What is the meaning of subtend? Subtend means to make. For example, look here. I'll explain you with the figure also one more time. The figure will be same in the second. Draw the same figure in the second. So here, say this, Prerna. AB is a chord, and with the help of the end points of this chord, we have made angle at the center. So this making of angle at the center with the help of chord, it means chord is subtending angle at the center. Means chord is making angle at the center. That's it. Yeah. So if the angle subtended by a chord at, of a circle are equal. Okay, I have not written one thing. Of a circle, after of a circle, no, right here at center, because angle should be at center only. Right here at center of a circle at center are equal. After that, write in given. Write in given that angles are given equal. Angle 1 and angle 2. And write in 2 proof that we have to prove chords are equal. AB and CD are equal. Proof. In triangle AOB and triangle COD, angle 1 and angle 2 are already given equal. And in the same way, AO is equal to CO and BO is equal to DO. Radii of same circle. So same way we have to prove this congruency also. So as two theorems are very easy to prove, just you have to keep this theorem in your mind. So therefore, triangle AOB is congruent to triangle COD by SAS congruence criteria. Side, angle, side. So very easy. By CBCD, you can write that AB and CD are equals. The chords are equal. It is proved by CPCD. Hence proved. I hope it is clear. Vivek is saying, sir, to explain theorem 2 one more time. Vivek, this is just the converse. You can say the opposite of the first theorem. In that we have proved that angles are equal and chords were given equal already. But in this theorem, chords we have to prove equal and angles are already given equal. See, if the angles subtended by chords are equal, if the angles subtended by chords at the center are equal, we have to prove that the chords are equal. So here we have to write in to prove that chords are equal. So just take these two triangles and write angle 1 and angle 2 equal. It is given. See this? Angle subtended by the chords are equal. It is given. So that's why we have written angle 1 and angle 2 are equal. After that, AO and CO and BO and DO are equal because these all are radii of same circle. The way we have done the first theorem, in the same way we have done the second theorem. This is just converse. In given, you have to write this, and to prove is this. After that, by SAS, we have proved that these two triangles are congruent to each other, side angle side. And by CBCD, ABCD are equal because AB and CD are the two chords which we have to prove equal. See, prove that the chords are equal. That we have proved. Done. Put the heading exercise 10.2. If you have understood it clearly, if you have understood these theorems clearly, theorem 1 and theorem 2, then the next exercise means 10.2 is very easy because that is also same as these theorems. That will exercise include only two questions, and both the questions based on these two theorems only. Question 1 related to the first theorem and question 2 related to the second theorem. That is also one more version of these two theorems. Let us do it. Exercise 10.2, question number 1. Read out question number 1, page number 173 in your book. Recall that two circles are congruent. You have to consider that there are two circles and both the circles are congruent. Can anyone tell me how we can draw two congruent circles? Anyone out of you, how we can draw two congruent circles? How we can say that two circles are congruent? What should be equal in two circles to make them congruent? So we, when there is written radius is equal, some have written same diameter. Okay, so those who are writing diameter equal or radius equal, they are correct. So approximately I have made two congruent circles with same radii. So just you can draw two circles with radii at 2 centimeter, or you can draw two circles with radii at 3 centimeter, whatever. So there should be two circles with same radius. If the radii of the two circles are same, it means the two circles are congruent. That's it. Okay, so no need to prove any congruency in circles. In circle, if you have to make two congruent circles, it means two circles with same area. For that, you have to make the same radius. Okay, that's it. Yeah. So these are the two circles which are congruent to each other. Now read further. And they have written if they have the same radii in the question itself. Prove that equal chords of congruent circles means now we have chords of two congruent circles. And both the chords are equal to each other. So let us make two equal chords. Let the center be point A, let the center be point B, and let this be P, Q, R, S, And in the question, it is written that, write in given that the chords are equal. PQ and RS are equal to each other. Yeah, you have to make these two circles. This is the figure for the first question. These two circles is a figure for the first question. As it is written that, prove that equal chords of congruent circles means we have to make two circles which are congruent to each other. Equal chords of congruent circles subtend equal angle at the center. So what we have to prove? We have to prove this. So just draw this neat and clean. Now we have to prove that this angle, let it be angle 1, and this angle sorry, let this be angle 2 are equal. So to prove angle 1 and angle 2 are equal, starting with the proving part, just take the two triangles in triangle APQ and triangle BRS, right? PQ and RS are equal because it is given in the question that chords are equal, right? Given. And after that, AP is equals to BR. What I have told you, this first question is the reflection of the first theorem. In first theorem we have done by triple S. This first question will also be by triple S, where where the chords are equal, and this radius will be equal to this radius. Anyone can tell me how now this radius is equal to this, but the circles are different. Now we can't write that radii of the same circle. So what to write? Radii of congruent circles. Radii of congruent circles. Because if we have two circles which are congruent to each other, it means they have the same radius. That's why it is congruent. No, so AP and BR are equal. Okay, and AQ and BS are also equal in the same way. Radii of congruent circles. Therefore, we can say that triangle APQ is congruent to triangle BRS by triple S congruence criteria, and angle 1 will be equal to angle 2 by CBCT, hence proved. There should not be any query in this question if you have understood theorem 1, because this is just the same as theorem 1, where there, what is the difference between the two? There we have drawn only one circle. In one circle we have drawn the two chords, and here we have drawn two chords in the two different congruent circles. That's it. And in proving, the difference is only of this word. There we have written radii of same circle, here radii of congruent circles. That's it, and everything is same. So first question is done. Now we have to do the second question. Note it down, be quick. The second question is just as this. Same figure we have to make in the second. Moving on to second. Now in second question, write quickly what is given in this question. No, just read the second question. Prove that if chords of congruent circles subtend equal angles at the center, it is already given that the angles are equal. Then we have to prove that the chords are equal. So PQ and RS we have to prove equal. And in proof, take the two triangles and prove congruent. That's it. In triangle PAQ and triangle RBS, right? Angle 1 and angle 2 are equal, given, and AP is equal to BR and AQ is equal to BS, and the reason being radii of congruent circles. And here also radii of congruent circles. Therefore, triangle PAQ is congruent to triangle RBS by SAS criteria, same as theorem 2. So therefore, by CPCT, we can say that PQ and RS are equal. The starting of the chapter is very easy. You'll feel it. Just practice the question one time in your practice notebook. You'll be able to understand these questions very easily. Okay, in given, no, I have not mentioned that the circles are congruent. You can write that also in given. That two circles are congruent. That also we can write in given. That because that is also given in the question. That circles are congruent. So here we can add this and given that two circles are congruent. In the first question also you can add this because this is also given. Two circles are congruent. Both the circles are congruent. Time's up. Come write it down and the lecture is over. And tomorrow we'll start with the theorems. Tomorrow our time, I think, will be busy throughout the lecture in the theorems only. We have many theorems to do. Then 10.3 exercise we'll do. Okay, bye. Take care and practice the questions. ITC.